Hello class. I'm going to do problems in homework 3, problems 2, 3, and 4. Problem 2 is really problem 10 in the book, page 127. Let me do the exact problem that's in the book. And it says, after plotting demand for 4 periods, an emergency room manager has concluded that a trend-adjusted exponential smoothing model is appropriate to predict future demand. The initial estimate of the trend is based on a net change of 30 for the 3 periods from 1 to 4 for an average of plus 10 units. Use alpha of 0.5, beta of 0.4, and a TAF of 250 for period 5. Obtain forecast from period 6 through 10. The problem is stated here in the red. The numbers that are in this trend-adjusted exponential smoothing tab are just what came up when I opened the software. I have to change mine. First thing I should probably look at is the data is from a different problem. So I probably want to eliminate that and enter our data, which is 210 for period 1, and so forth. So this is where you would enter the actual data. And you see I have 9 periods, and I have a forecast that's meaningless on a 9 period. The blue line is the actual data, the red is the forecast. Now why is the red going in the wrong direction? Because at period 5, I have 733 as the TAF, or the initial seed for the forecast. This problem says our TAF should be 250. So let's put in 250 there. And all of a sudden the line changes dramatically. And I have forecasts here. Let me change these forecasts and make them 2 decimal places, just so they don't grow in decimal length and they all look uniform. We're not near the right answer yet. Period 5 is when we're putting in the TAF, and I think that is exactly what the problem said to do. TAF of 250 for period 5, correct. Now our trend, as you can see, is plus 10 units. So I put that in. That changes the line a little bit. And my alpha for this problem is 0.5, so I put it in where alpha is. Now don't change, this change in alpha is kind of interesting because if I toggle the switch, it changes it by 0.1, 0.2, and you can see where it's going. So let me change it back to 0.5. In 0.3, for the beta, it's not 0.3, it's 0.4 in our model. So I can actually just increase it this way, and that's our model. It's given us a forecast based on every month going up by 10 and using exponential smoothing on the actual, combining the smoothing and the trend to come up with this red line, which tracks the blue line very nicely and provides a forecast. We're looking for a forecast from period 6 through 10. Periods 6 through 10 are right there. That would be our forecast. It's highlighted in yellow. And if you do the problem in the book, that should be exactly how you do it. It doesn't take but a few minutes, but you have to kind of know how the software works. Let's move on to problem 11. Problem 11 is trend and seasonality. And the problem here is written in red. And the problem reads, a store manager that sells and installs spas wants to prepare a forecast for January, February, and March of next year. Her forecasts are a combination of trend and seasonality. She uses the following equation to estimate the trend component of the monthly demand. F of t equals 70 plus 5t, where t equals 0, in June of last year. So this company obviously has a fiscal year that starts in July. Seasonal relatives are 110 for January, 102 for February, and 95 for March. What demand should she predict? Well, let's make this kind of simple so we can see what we're doing. Let's enter our months here, which you can do in this software. It's not January. It said that if 0 was June, what is 1? 1 is July, 2 is August, 3 is September, and so forth. So I put the months there just as a guide, because rather than the numbers 1 through 12 won't clearly indicate which is January through March, which is our period we want to forecast. So we're going, November is 5. So we can see January through February, January through March, highlighted in yellow, are months 7, 8, and 9. And we want to put in our indices. Now they've told us the seasonality for those months, because this is where I put the seasonal index right here. Season, okay, it's a 12-month season, 1 year, each season, each period being a month. The index, they've only given us for January, February, and March. So for January, it was 1.1. For February, it was 1.02. And for March, it was 0.95. Now I have all these other numbers, which I really want to get rid of. But I don't want to leave it as 0, because you'll see I have a blue line for the trend, and the forecast is the dotted line. So having 0 as the index won't work. It multiplies it by the index. So where I don't have an index, I can just assume it's going to be 1. And there's my trend, there's my actual forecast. Now, let's put the slope and intercept in for the trend part of this. What was the slope? Well, here it says 70 plus 5t. So my slope is going to be 5. And you see it changed the slope of the entire forecast and trend. And my intercept at time 0, which was June of the first year, or the first year minus 1, was 70. So there we go. I have, and what are my number of seasons? Right now it says 4, that's why it looks like a straight line. We've moved it from 4 to a 12-month, 12 season. And you see now that the blue line is the trend, and the forecast for every place we've put a 1 is actually on that blue forecast line. And just in January, February, and March, where we have different seasonality numbers, you can see it changes. If I want to, well, I can't change that graph, it won't let me. So let's leave it as it is. Now we go down here to see where the period, the season, the trend, and the index, and giving me the final forecast tells me, what do I have? Well, I have my January 7, 8, 9 is always January. So it goes by period successive up to 60, but then it tells me what the season is within each period. So the first 12 match up, the next 12 match up. They wanted the forecast for next January, February, and March. Prepare a forecast for January, February, and March of next year. Well, how do we do next year? Next year is at the coming January, February, March. If you put that in, you will get it wrong. What they mean by next year, and this is only by trial and error on my part, next year means months, periods 19, 20, and 21, which is 7, 8, and 9 of the following year. So if this year is 2014, January, February, March would be 2015. If we're doing a forecast in July of this year, 2014, the January, February, and March of the next year would be 2016. So here is the forecast that you would put in. And if you want to make them all 2 decimal places, you can do that, but it's not as necessary. It was in the previous problem. There's our forecast. Okay, let's go to the last problem, which is actually on a different spreadsheet, and that's problem 15. If I look at problem 15, here's the problem. The manager of a fashionable restaurant opened Wednesday through Saturday, says that the restaurant does about 35% of its business on Friday, 30% on Saturday, and 20% on Thursday night. What seasonal relatives describe this situation? Well, there's my actual percentage, and I'm going to put the percentage in as decimals because I can, or that's the way I prefer to do it. What do I want to do? So it says 35% of its business on Friday, 0.35. What percent on Saturday? 0.3. What percent of the business is done on Thursday? 0.2. Well, I'd like to have them all the same decimal places. If I want to make them all percentages, I could do that here. I could either do this and make them all decimals, or I could do this and make them all percentages. Let's leave them as percentages. Why not? What is Wednesday? Well, by process of elimination, it's equal to 100, or 1 in this case, minus, because 1 is 100%, minus, let's take the sum of the other three that we know, and it tells me my sum is 15. Does that add up to 100%? Yes, it does. So now I can look at number of periods. And how many periods are there? The restaurant's only open 4 nights, so it's all 4. Seasonal relative equals the percentage times 4, which gives me 0.6. And it takes it down to, if I want to make it 2 decimal places, I can add a decimal place to it. 0.6, 0.8, 0.4, and 0.12. Or 1.4 and 1.2, excuse me. What is the average of those? The average of the seasonality has to be 1, and it is. So those are my seasonal relatives. And this ends the video on using the software. I did not use the software for the seasonal relative, but I used the software that comes with the book for the other 2 problems. In another video, I will present doing the other 2 problems, problems 2 and 3, using Excel only, not using the software that comes with the book. So you can see 2 perspectives of doing it. Thank you very much.